We're going to do two examples of thermal expansion in this video. The first is going to be on linear expansion and the second on volume expansion. For linear expansion, let's say that you have two poles, one made of brass and the other made of iron. Each are 6.2 meters long in the morning when the temperature is 65 degrees Fahrenheit, which would be 18.33 degrees Celsius. We want to know which pole is longer in the middle of the day, assuming a high temperature for the day is 87 degrees Fahrenheit, which would be 30.56 degrees Celsius. Okay, so remember our equation for linear expansion is that the new length is going to be your initial length times 1 plus alpha times your change in temperature. All right, so let's move to the side here and say change in temperature would be final minus initial. This does need to be in degrees Celsius because your coefficient is in inverse degrees Celsius. So this is going to be 30.56 degrees Celsius minus 18.33 degrees Celsius. Remember, final minus initial. That gives us a difference of 12.23 degrees Celsius. All right, so we are going to be dealing with two substances. One is brass, which I will mark right here, and the other is iron, which you see right here. Okay, let's deal with the brass first. So the length of the brass is going to be its initial length, which is, I'll go ahead and put that in there, 6.20 meters, times 1 plus its coefficient, which we just saw here, is 19 times 10 to the minus 6th inverse degrees Celsius, times the change in temperature, which was 12.23 degrees Celsius. All right, if we simplify that a little bit more, we get 1 plus the coefficient times the change in temperature will be 0.000232237. And the units cancel out. You have no units left, so we're good. So now we just add 1, so that's 1.000232237 times 6.2, giving you a final length for the brass of 6.20144 meters. You only have 3 significant figures to start with, so that's going to become 6.20. We're going to say 6.201 meters. Now we're probably going to need those extra significant figures just for comparison. But let's move on to the iron just to see what happens. So for the iron, follow the exact same equation. Length is going to equal your initial length, 6.20 meters, times 1 plus its coefficient, which is 12 times 10 to the minus 6th inverse degrees Celsius, times the change in temperature, which was 12.23 degrees Celsius. Once again, units all cancel out. Gives me a length of 6.20 meters times 1 plus, multiply these two terms together, you get 0.000146676. Now that math is pretty easy from there. So you end up with a total length of 6.20091 meters. Again, 3 significant figures, 6.20, and you can see here if I round to just 3 significant figures, I get exactly the same number that I started with. So in this case, it's hard to tell what the exact number is because of significant figures, but it is clear enough to say that the longer one, so we're looking at which pole is longer. Whoops, that was supposed to be a highlighter. Let's try this again. The longer pole is going to be the brass. Okay, let's do our second example. We have a 50-liter steel tank the steel gas tank, and you fill it up to the brim on a hot day, 40 degrees Celsius. That night, a cold front hits and the temperature drops down to 10 degrees Celsius. How much room is in the gas tank after the tank and gas have both cooled? Well, remember that our equation is now volume. We're dealing with volume since we're dealing with liquids. But the equation is essentially the same, just a different coefficient. Our change in temperature is going to be 40 degrees Celsius minus 10 degrees Celsius, which is 30 degrees Celsius. Okay, so we have a steel gas tank. Sorry, I almost crossed out the number there. And we are dealing with, oh, what color is gasoline? I don't know. We'll do green. I know it's not green, but it's good enough for this video here. Okay, so those are the two numbers that we're going to be needing. Let's go ahead and do the tank first. And find that the final volume of the gas tank is going to be its initial volume, which is 50 liters, times 1 plus beta, which would be 35 times 10 to the minus 6 degrees Celsius inverted in this case. And I just realized I made a mistake earlier. I hope some of you guys caught what I just did. Remember that change in temperature is always final minus initial. I did initial minus final. So let me come back here and fix that. This should be final temperature minus initial temperature, which gives me a temperature decrease of 30 degrees Celsius. That's going to be important because that negative 30 degrees Celsius is what causes the gas tank to shrink. All right, so my volume then is going to be 50 liters times 1 plus, both of those multiplied together, gives me a negative 0.0285, or 50.0 liters times 0.9715, which gives me a total volume of 40. I'm sorry, I'm using wrong numbers here. These are the numbers for the gasoline that I'm using here. So let me come back here. For the tank, the number would be negative 0.00105. Add 1 to that, and you get 0.99895. Multiply those together, and you get 49.9475 liters. And so the gas tank has shrunk. Well, not only has the gas tank shrunk, but so has the gasoline itself. Following the exact same procedure, 50 liters of gasoline, its coefficient is 950 times 10 to the minus 6th inverse degrees Celsius, times, again, our change in temperature is negative 30 degrees Celsius, which would give us 50 liters times 1 plus, and this would be a negative 0.0285. That's the number I had earlier. I apologize for that. Which then would simplify to 50 liters times 0.9715, giving me a total volume of 48.575 liters. So there you go. We know that the gasoline has shrunk more. And because of that, that's going to leave a little gap at the top of the tank. So now our tank is not completely full anymore. So the space at the top is going to be the final volume of the tank minus the final volume of the gasoline. The volume of the tank we found to be 49.9475 liters, and the gasoline was 48.575 liters. Okay, so if I take that difference, 49.9475 minus 48.575, correct, I get a volume of 1.3725 liters. Now, three significant figures. We haven't been rounding to significant figures recently, so the volume you have is somewhere around 1.37 liters. You could fit another 1.37 liters of gasoline into your tank.